Okay, in this tutorial, this is for week 4 um, assignment in the material science class. Go ahead and go and click on week 4, and it'll take you to this page. Click on the um, week 4 assignment, and this is basically what we're doing. Um, we have finished up the case study. Um, Not finished completely, but finished a portion of it for the foundation. So this is what the, oh, not sorry, case study, the portfolio. So this is what it should look like. If actually we go back to the folder, it's right here. Click on that, and you'll get to see all the different slides and what they're supposed to look like. So go ahead and take a look at those. Make sure your slides look exactly like this, and you should be good to go. These first couple slides is, well, obviously this is the title page. Don't put your name, or leave my name, put your name. Take my name off and put your name. I've had students last semester put in my name with their work. This is your work, take credit for it, put your name. All right, so this first slide, this is pre-construction. This is a lot of the planning phase of construction. First starts off with a client having acquired land or a plot. Acquisition and just means to obtain, to get. So acquisition, acquired is from the same word. Once that happens, they'll seek professional help from the architect. The architect is pretty much the essential person that a client can go to for design, and typically an architect will interview the client as to what they need. We can't read what's going on in people's ideas and minds, and so we basically have to, have a little chat and say, hey, what do you plan on doing with this land? And jot down notes as architects do, and as the conversation goes, and they'll go back to the office and try and design something that the client will like. And they'll come back to the client, hey, finish the design. Let's set up another meeting to take a look at it. And at that meeting, the client will say, you know what, I like it, let's do this. Or, you know what, can we change this? Can we change that? And then see how that looks. And, the architect agrees with that. And, because sometimes the architects say, I really did it this way because of this, because of that. And they kind of defend their decisions in their design. And sometimes that might convince the client, say, hey, you know what, that makes a lot more sense than my idea. And it's not, the architect wins, the client loses. It's a win-win for the client and the architect. Because one thing about designing in architecture is that if the client decides to go with their own ideas, and you just allow them to do their own ideas, and they don't like their own ideas, they might just blame the architect. And so that's why it's kind of important to defend some of your work, but not in a rude way, obviously, just a friendly way, a professional way, where you can say, this is really why I designed this particular way. I get what you're saying, but I just want to reiterate that, and really make their point. So you can see how that goes. And that's something that is developed over time. You don't learn that right away going through school. You learn that as you work in the profession. And so, once the client says, you know what, yeah, thank you for the revisions. This is great. Client signs off on it, and the architect will hire an engineer to do the engineering. And if that's what the client wants, unless the client has their own engineer, typically the client may not and ask about engineers, and depending on the kind of service the architect provides, it might be all inclusive where he or she works with a particular engineer that they like and say, hey, I can get all these drawings done for X amount of dollars, and where the client doesn't even have to worry about engineers, and the architects just takes care of it all. Um, and they'll get the engineers for the electrical, plumbing, and mechanical. If there's a geotechnical soils engineer, they'll get one of those for that to check and make sure that the soils can handle the amount of weight that they're about to put on the soil. The foundation, all the materials on the foundation, everything. So everything has to get checked out. And once that happens, the architect can prepare a budget for time of the project completion to the total cost of the design and building of the structure to include labor. So the architect can include a budget for everything if that's the type of business that he or she runs. And there are some architects that do that, and they're called design build firms, where they do it all. They design it, engineer it, and they build it. And so they can produce a budget for that, or estimate for that. And another thing about budget is that's part of the conversation you have to have with the client. What kind of budget are we looking at for this particular project? And so when the architect does design for the client, they have to keep that budget in mind, make sure that it's not going to cost too much and go way over budget, because some clients only have a certain amount of money. It's rare that you have clients that have millions and millions of dollars, and even if they do, they're not going to want to spend it all. So it's always important to know how to design for a budget, and you learn that through working at a firm, and you slowly work your way to understanding and estimating for a budget. Okay, and then once that all gets approved by the client, then the architect will also collect all the drawings from the engineers needed to submit to the city, and not just the city. Sometimes you have to submit to the fire department. Sometimes the fire marshal needs to see the plans and approve it to make sure everybody can get out safely, and where there's ingress and egress. Ingress meaning a way in, and egress meaning a way out. And so fire marshal had to check that out. When you drop it off to the city, they have city plan reviewers, which are people that were architects, or still are architects, and engineers. And so engineers will check out the engineering plans and the structural plans, mechanical, electrical, plumbing, all of it. And they want to make sure that people aren't cutting corners or designing right according to the building code. And if you're missing something, obviously, more eyes that see it, the better. So the city will let you know, like, hey, you're missing this, that on the plan. Go ahead and put that on the plan and resubmit. And then once you resubmit the plans, typically on your second try, if you put everything that the city plan reviewers said to put back on the plans, you're done. You'll have your permit. And once you get your permit, you can start building. But I want to mention some other authorities that you may have to encounter. Beaches and harbor. If you build close to the beach or close to any harbor, they want to make sure nothing harms the marine life. So you might have to submit plans to them. Homeowners associations. If you're unfamiliar with homeowners associations, they're basically communities that are gated, and they charge people that buy houses in them to have that gated community lifestyle. And they have other amenities in there, like they might have a gym inside that community that only the people that live there can use, or a pool. a public pool or public park that only the people that live in that community can use. And so they charge monthly fees for this homeowners association um, community life, and it's basically a group of people that kind of just run that community and make sure it's operating um, as it should. Uh, you might have to get approval for them to do any additions or any renovations, because homeowners associations do not allow any changes unless it comes through them. And the cities know this. So if you go to submit plans to the city and they're like, hey, did you get permission from the homeowners association? The city knows. The city knows exactly where you live, and they know who has a homeowners association and who doesn't. And so they'll ask for it. And so if you didn't go through the homeowners association, then they'll reject your plans. They won't even take them. They'll come back when you get permission from the homeowners association. They're also known as the HOA. I've gone through the fire department, the homeowners association, beaches and harbor, and it's just one of those things that you have to do. It's not easy to get a permit to build. The reason why we have everyone do this is because everybody wants everybody to be safe about doing their job. So, like the health department, you got to go to the health department, especially if you're working on a restaurant or you're working on a bakery or anything that deals with food. You got to go through the health department. The health department needs to check to make sure that there's certain materials that are scoped out and chosen for cleanliness. Think about the restaurants that you attend. It has an A rating, and then you've seen other restaurants where there's a B, and you're like, I don't know if we should do this, but you know what? Oh well, I'm hungry. Obviously, there's no D or F restaurants, so you really shut them down after there's a D. And a C, they're really close to shutting them down. They probably should just shut them down. But don't quote me on that. I'm sure there's procedures that I don't know about when it comes to running and operating a restaurant. But I do know that the health department needs certain things for a restaurant, and especially equipment and tile and hot water heaters, and they want to make sure everything is safe for the public health to eat and dine at these establishments. And so once you get approval through whoever the city says you need to get approval to from, then they'll approve the plans. And once they approve the plans, they literally stamp them and they sign them. There's a massive city stamp that you'll see on these plans, and they'll sign off on them. And once they sign off on them, then you can go and build. You have a certain amount of time to build. And so you can't take forever to build. And so typically, once these plans are in the city, they can take anywhere from 2 to 3 weeks to get back to you. During that time, the client might approach you and say, hey, do you know anyone who knows how to build this? Like, do you have any general contractors? And general contractors are typically the people or the company or person that will assume responsibility for the entire build of the structure. And sometimes they can't do it all. So, like, say if they don't know how to do plumbing or electrical or I don't know, mechanical, where they're installing air conditioning ducts and stuff. Let's say they they don't know how to do that. They can hire other contractors to do that as a supplement to them not being able to know how to do it. And so those are called subcontractors. And they'll fill in the gaps where the general contractor, doesn't know how to do or is not an expert in installation of certain things. Plumbing's a big deal. You should be a plumber to know how to do an entire plumbing system. And as a general contractor, you have a general idea of how it's supposed to be, but if you're not used to doing that day in and day out, you're not going to get a good plumbing system going. So somebody that knows how to do that day in and day out should be doing that. And then you got construction project the going on. Once you get the plans back and the client says, okay, well, you know what, let's go with your general contractor, or I have my own general contractor, and they'll sign a contract through the general contractor, separate contract from the architect, unless the architect's a design builder where, you know, there's in-house general contractors, and you know, they can get it built. However, you know, once that's all said and done, then they can go build. Once they get the plans back from the city, they can go build, and it's approved, they can go build. And so the first part is site preparation, where the leveling of the soil, you know, may require, some cities may require a soils technical engineer for a corrective solution if the soil, the dirt, and the dirt underneath, you know, everything underneath the dirt is unfavorable, meaning if you build on it, you know, it might turn into the Leaning Tower of Pisa after so many years. And that's my greatest example when I talk about geotechnical soils engineers is the Leaning Tower of Pisa. Nobody decided to check and see how soft the land was before they built that structure, and it started to sink right away. And thankfully, it hasn't fallen completely over. But I do recall reading that they are currently really, really afraid of it falling over after all these years. So they have engineers and stuff working on it to make sure that it doesn't fall over and it still stays leaning. So I don't know what, I haven't stayed current on it, but I know they were worried recently about it falling over because when they first built it, there was no such thing as geotechnical soils engineer. And once it started sinking on one side, that's when they're like, all right, we need somebody to really study these soils and make sure that we can build on them, so we don't have this happen again. Unfavorable soils may require piers, basically columns or screw piers for lightweight construction and concrete, and some piers are concrete piers, you know, down all the way to bedrock for heavy construction, like the skyscrapers in downtown LA. I'm sure all that foundation is all the way down to bedrock with these piers, these concrete piers, to make sure that it can hold, you know, those heavy structures. The foundation is built with steel, rebar, concrete. The site will have the dirt dug up, you know, per the structural engineer plans, and rebar will be set in the holes. Wood forms will be placed so concrete can be poured. And here's typical concrete foundations. This is what you'll see typically in a house foundation in California. Sometimes you might see something like this, where you'll have reinforcement bars, also known as rebar. And you might have soils and engineer that says, okay, you need gravel underneath. And so, you know, that might be a thing. And then you have the rebar going all the way across the top. This is the slab part of it right here. And this is considered the footing. And then right here you have an anchor bolt. And that's typical. That's really, really typical. And this is what it looks like after it's been poured. I mean, this is still wet. The forms are still up. These wood forms. So, you know, concrete's, you know, very viscous. Viscous is like a liquid, almost liquid-like, but it's really thick. If you've ever mixed concrete before, it's almost like an oatmeal with rocks in it. So you need something to form it in order to create the shape that you want it to create. And so that's forms, and you can see the rebar coming out. And then we talk about the different materials, because this is a material science class. And so one of the materials for concrete is Portland cement. It's a powder, and we don't just use that by itself. And I know some people misspeak and like, oh, I hit my head on the cement or skid my knee on the cement. Well, that's not technically true. It's concrete, and cement is a powder form. Concrete is a combination of cement, sand, aggregate, and water. And so sometimes they'll just use sand, sometimes they'll use a combination of sand and aggregate, sometimes they'll just use aggregate. Aggregate is just gravel, and then you'll get this mosaic looking where you see all these little rocks and stuff like that. And we use rocks because rocks are strong and they can hold weight. They're not going to crack under pressure. And that's what concrete really is. I also added that concrete can be mixed with additives to speed up or slow down the drying process. Additives are just chemicals. And the reason why we speed up the drying process is in colder climates. If it's too cold, the water's not going to dry up in the concrete in order for it to be solid. So they'll mix in chemicals to literally bake the concrete dry of all water. You can think of places like Chicago or New York where it snows, and if it's too cold, the water's not going to evaporate from the concrete. And inversely, on the flip side, you'll have chemicals that slow down the curing process, the drying process. Because you have places like Phoenix, Arizona, and Las Vegas, Nevada, where it can get to 100 to 120, 130, and you got these cement trucks that are big hunks of metal sitting out in the sun. What happens to hunks of metal that sit out in the sun? Well, the metal heats up, and that big drum sitting on the back of that truck is like an oven, and so it can dry up that concrete really, really quick. And that's why we need to slow down the curing process, because the truck needs to get from the place where they start to mix the concrete to the job site, and it could take up to 20-30 minutes. And if it takes too long, it'll harden, and then not only is the cement ruined, but the truck is ruined. So that's why they do the additives to speed up or slow down the drying process. Next, we have the rebar material. It's composed of steel or fiberglass. There's other forms, but we're just going to go over these two. And it can reinforce concrete up to 1,000 times stronger than concrete alone. I know that the word alone didn't quite make it out, but it's alone. Try and find the same picture, not the same picture, but similar pictures. Like, you should have similar pictures in your presentation. So when you type this up, you should have similar pictures. Yeah, sometimes there's a stainless steel rebar to prevent corrosion. If you'll notice, there's a little rust color in this rebar because it is actually rusting. Steel by itself will rust, and sometimes they'll coat the rebar with epoxy. Fiberglass doesn't rust; it doesn't corrode. So sometimes they can use that. It really depends on the application and what the engineer suggests. But steel rebar is the cheapest, and anything after that is a little bit more expensive. All right, the next we have is anchor bolts. These are made from galvanized steel, and galvanized steel is, whenever you see the term galvanized, it means it has a protective zinc coating to prevent corrosion. what these anchor bolts do is they'll sit on top of the um, foundation sticking out, so you can slide the wall down on top of it. This bolt will stick out above the wood, and then yeah, and then this, you can screw down this nut onto the wood, and this will hold the whole entire house, literally bolt it down to the foundation. And I asked in class, why does this anchor bolt have a curve? Well, imagine if it was just straight. You could pull it straight out. And the whole purpose of anchor bolts to anchor the entire house or structure down to the foundation is we live in a state where there's earthquakes, and whenever it shakes, the house can slide off the foundation. And to prevent that, we bolt them down. We bolt them down to make sure that they don't slide off the foundation. Because if a house slides off the foundation, the house is done. And people spend a lifetime of time working and making money to invest in a house, and for it to slide off a foundation and just be completely ruined would destroy a family financially. And so that's why we bolt these down. And this hook at the end, when the concrete dries, it doesn't allow this bolt to slide out. That's why we have that hook. And so this is what your slides should look like. And then we got into practicing using Sketchup. So if you go to week 4 folder and go to week 4 assignment, creating foundation in Sketchup, click on here. You'll be able to log in using your school's Gmail. And here we go. Here we go. And so you can create a new folder or a new file. I like to save it. It'll save to your Google Drive, your school's Google Drive. So click on that, and this is material science. So I'll go ahead and if you don't know how to make a folder, it's just right here. I've already made folders. So if you don't have any folders at all, make a new folder for material science, and then whatever period you're in. So P 2 if you're in period 2, or however you do it. But yeah, that that's how you can do that. And so I've already created folders, so I'm not going to do that. We'll go ahead and just click on a folder, and yeah, once you create the folder, click on the folder that you just created, and that way it opens up, and then name the file Sketchup. Practice commands. And I'm going to put this at 1.1 because I already created the file. And basically, we're just going to practice. Yeah, once you set up here, I'm going to go ahead and make another video for practicing. So that's it for this video. The next video, I'm going to show you how to practice the different commands.